Okay, good afternoon, everybody. This is our last lab. Please don't forget to put your pluses in chat for marking your attendance. Okay, so today is like our last lab for this course. It will be more relaxing this time around, and we will cover some object tracking with OpenCV, just how to use it. You're not gonna implement some algorithm from scratch, just detecting objects and using object tracking. Let me share the screen. Okay, so as in our each lab, first you will download these two videos. Let me show you if I can. Can you see the video?
Yes.
Yes. So this is the first one where you will have to detect this red object and then track it in the following frames. Because as you know, in all our previous labs, also in some of them, we already worked with videos. And each and every video consists of many frames. So once you will load or read the video, you will keep on checking, like, the first frame, is the red object present there or not, and so on and so on. And once you found this red object, then you will return the bounding box. And near this red object, bounding box, and for the following frame, you will just pass these bounding box coordinates to your object tracker, and it will do the following work for you, rather than just detecting object at each and every frame of the video, which may be like very resource consuming if you will be using deep learning, for example, which large models take some time to process. So the first part is just with red objects. No, it's not like some hard object detection technique or something. Last year we gave this task on a midterm. So here is the solution is already given. So as you might have an idea, like how we detect these red objects, it's just like we did on the first lab with HLS color space when we were detecting red eyes. Here we do exactly the same, but in the RGB color space. So manually tuning a little bit of parameters for colors, and we can find this object. Then again, we just find contours near this object, draw center, and return square bounding box. And it's upper left coordinate, if I'm not mistaken. Okay, do you have any questions about this detect red function, why it looks like this? And then you will have to create tracker. Not there is nothing hard here, and code is even written already. So here we just specify, like there are a bunch of different object tracking techniques already available, of course, in OpenCV. Existing approaches are even more than listed here. So you will be able to play like by trying all of these different trackers. You can see which one works better, which one works faster. Some of them, like this tracker, for example, don't use information about all previous frames because like, we were tracking object for some time, right? So we have some information already on which direction it tends to go, how it tends to move. Some of them using this kind of information, some of them don't. So you can try to play, and if you're interested, you can go more deeper in some of them and read about them. So for the exercises, first what you will need to implement is track function, which takes as an input, of course, video on which we will need to track the object, a frame which is this frame here. So it's a frame of the on which we found the object at the first time where object is present. And then bounding box is the coordinate of bounding box near this object. So it's leftmost top coordinate and rightmost lower coordinate. Output writer is where we want to save our output detected video. A number of frames is like number of frames to consider. Like here in the loop, we will just iterate over number of frames and not go deeper even if a video is longer. So what you will need to do here, you will need to just initialize your tracker with the function that we already specified earlier. And then you will need to use some kind of track method of the tracker by sending it the object coordinates on initial frame so that your tracker knows which object it needs to track. That's it. So the methods to read each and every frame of the video is already given here. You only need to specify the logic here, which is like 1 or 2 lines of using the tracker itself, and that's it. Okay, so this method, this function will make everything logical. Like this small function is just tracking the object given that we already detected it. So here what we want you to do is to recognize, detect the object itself. For the first exercise, red object, and then with the function that already was defined earlier, which is already implemented even. So here, once you found this object, you will like break this loop and pass the detected object and the rest of the video to the previously specified function track. Is it understandable? So here, I think comments are pretty understandable. So if you didn't understand something now, you will be able to do that later on. So, and the last part is just we call all whatever we were doing in upper sections. So first example was when we were detecting just simple example of finding red object by its color only. But here, by the way, let me show you how the resulting output should look like. It would look something like this. So at some point, tracker loses the object and then you have to detect it. Might have to detect it again to track in the following frames. Okay, here is another example and the second video, which you cannot do with the first function that detects only red objects, because here what you want to do is you want to track cars. And for that, we will use SSD method, single shot multi-box detector. I guess you already also know about this. Is a quite famous object detection technique based on deep learning, which is pretty similar to, the idea is pretty similar to YOLO, also uses CNN, and they released almost in the same time. SSD was a little bit later. So here is the output that you will get. Some kind of like this. So for this case, we will use a TensorFlow implementation of SSD. In previous labs, we usually used PyTorch, maybe in one only lab. Okay, so here we also use TensorFlow implementation. So this is the way we load the detector. And then we have a method, filter boxes, that will filter out weak predictions, what we consider weak, according to our mean score. And we will specify only one class of interest. So for this task, for the second exercise, you only need to detect cars. So we don't need all other classes. That's why we are going to filter them out. We will only leave cars. And max boxes is like we'll have only maximum 10 objects on one frame at a time. So here is again a project that you already implemented. Or something like this you already did when we were studying YOLA. So here it is. Like filtering is already implemented now. I think it's quite understandable. Besides maybe this part that is needed to define leftmost top coordinate and rightmost bottom coordinate. Okay, then there is a method detect that calls detector itself and then calls filter boxes. It was already here. And returns bounding boxes of objects that you are gonna track in the following methods. So on the first example, what you will need to do is just track one object. Here you will have multiple bounding boxes. So you will try to find out how to use same trackers, but you will need to pass like multiple bounding box coordinates to the tracker and then run exactly the same process as with previous case. And again, last thing to implement is detect object and track, which will do a whole thing for you. Like the whole logic will be implemented here. You will detect, you will run SSD here, you will get bounding box coordinates here, and then you will call track multiple on your video for the specified number of frames that you want to be detected and get the output video as it was here. And these lines are just calling all previous things. So do you have any questions about this lab? If not, then let's a little bit talk about the course itself. So this is the last lab. Tomorrow morning, like for this lab attendance, I will put today, hopefully in the evening. So please, tomorrow morning or on next week, check if I marked everything, all labs that you attended in Moodle, that I didn't make any mistake. Then also next Thursday, you will have, some of you or all of you will have project presentations during lecture time and during lab time also. The schedules...
By next Thursday, you mean this week?
This week, I think, yes, some groups already have scheduled.
Yeah, this week.
This week, yes. Please check it in Moodle, in attendance section. Fahim and other TA, they put schedules for you. So information should be available there.
We should attend only one meeting, I mean, where we present, or we should attend all of them?
No, I think you don't need to attend all of them.
Okay, we should attend only our
Yes.
our class, okay.
And exam is going to be at 12th of October. It again will be first exam from Fahim. Like you will have something in Moodle as it was last time. And the one lab exam, again, which we didn't prepare yet, but we hope we will prepare it next week, Monday. It will already be prepared, and then we will put the information again in Moodle in announcement section on how it will be conducted. It will have again same structure as it was before. Okay. And your homework is still in process. So hopefully on next week you will get your grades for homework, for second homework, and that's it. It will be that's it.
Okay, also I would like to ask about the exam. It would cover the whole material from the beginning of the course to the end, or from the midterm to the end?
According about lab exam, I don't know yet. Like maybe you will need to use some lab materials from first labs also, but again, as it was before, you will have access to all of the labs. So if you implement it, everything is okay. But we will put it in announcement section, I guess. But according to written exam, yes, it will be based only on material which was covered after the midterm.
Thank you.
Okay, I think that's it.
Thank you very much. Goodbye.
Okay, you're free to leave the chat. Goodbye. The conference.